I hope that you're getting ready for tomorrow's test. Today is not really the day for us to review. We did that yesterday. But what I did do was I did extend the homework I'm assigning today another day so that you can spend tonight with studying for your test for tomorrow. Hopefully that'll help. So, what we're going to do is we're going to move into a chapter 4 topic called simulations. So, hopefully, you printed out uh, packet pages 7 through 9 and a random digit table. If not, then you're just going to have to follow along and do the best you can with it. So, let's go ahead and start out with this. Just some background for you. And one of the big things that we have to deal with in statistics is dealing with randomness because, we're dealing a lot with sampling and with outcomes that we're trying to get some kind of handle on. And it just turns out that if we get a sample of like 15 people and measure their height and get an average, then the next group of 15 will be a little different. And the group after that will be a little different. And it just goes on and on like that. And so we need tools to not only handle the random behavior that's just normal, but we can sometimes use it to our favor. So that's what we're going to be doing today. So random phenomenon, whenever I picture something that's random, I always picture like a box with the theory of molecular motion inside with all these little balls going every which way, kind of haphazardly. And it may seem that as you deal with random phenomena that you'll get that impression. But what happens is you're going to see a kind of order emerging in the long run as outcome generating activities are repeated. So if I start finding groups of families with 6 kids, and my question is like, what is the proportion of boys that are born among 6 kids? Well, we know that would average about 0.3. I'm sorry, 0.5 rather. But if you just look at the first group, they may have 2 boys. The next group may have 4 boys. The next group may have 0 boys, and so on and so on. So you're seeing this kind of haphazard result when you look at individual outcomes, but you have to hang in there. And so if you look at all of those numbers of boys or percentages of boys that are being born, and you average them over like 100 or 1,000 or 10,000 or a million different chances like that, then you will see a 50-50 breakdown for boys and girls as far as the proportion of them being born. But you have to, wait until that pattern emerges. So if we were to just kind of wait around for people to be born, that may just take too long, if we're in a situation like that, so that we can just substitute our approach for what's actually happening and work through simulation. So that's what I'm going to try to train you at today, is how to handle simulations. So here's how we run one. Now we're not going to be quite this formal, but it's going to be the basis for how to handle a simulation, like identifying a component that's repeated, like having kids. And then explain how we're going to model the component's outcomes. So we will do that by assigning digits. So 0 to 4 will represent a girl. So if we generate random numbers, and any number that's 0 through 4 will be representative of a girl. 5 through 9 would be for boys. There's your 50-50 split, right? And we don't need any more than just single numbers for something like that, because you don't want to get too complicated. We could do it with double digits or triple digits, but if you don't have to, you want to keep it simple. We can use a random digit table, which we'll learn about today. Your calculator can generate random numbers. We'll use that too. You can pick stuff out of a hat. You can roll dice. You can flip coins. You can do anything that has random behavior that we can model or simulate for things that happen in the real world. So state clearly what we're measuring. Maybe we're interested in the number of boys we can expect in 10 births, you know. Then you have to run many trials to overcome that haphazard appearance that you get from individual outcomes to start seeing what the true values are. Number 6, yeah, we'll collect and summarize the results of the trials, but we're not graphing and we're not describing any graphs. That's maybe just a step too far. And then the very last thing is to communicate whatever it is that you found from your simulation. So this will be a model for how to run them. And we're going to also use a random digit table. And those things are available. Well, I put them just about everywhere. There's a download for it. You can get one from reprints in chapter 4. There's one in your book. It's labeled T5. There's one at the end of your packet, the very last page. They're everywhere. I probably snuck one into your house and you'll find it in like 5 or 10 years and wonder where that came from. But they're everywhere. In fact, if you want, you can Google random digit table and it'll appear in all sorts of places. The crazy thing about it is there's only one, right? So even if you download from some other source, it's going to contain the same numbers in the same order because somebody made it up a long time ago and then everybody agreed that's what we're using. So that's what we're using. So it's a table of numbers. There are no patterns. All the numbers are independent. So if you get like a 1, and a 1, you know, in a row, that can happen with things that are truly random. If you then decide the next number can't be a 1, you might be disappointed because what you got before doesn't tell you what's going to happen next. So these numbers are independent. And we're going to use it for simulations. Okay, so when we start looking at it, each row in that table starts with 3 numbers that are not part of the table, right? So, and kids make that mistake all the time. So row 150, for example, is just for me to say, if you will look at row 150, we'll all look at the same row. It's an identifier number. So the first column has 3 digits in it, numbers with 3 digits. Those just identify the rows. We don't use them for any kind of simulation. They are arranged in groups of 5, and I guess they're supposed to help the user not lose their place. But this is a tough kind of thing. I mean, you got to have a good eye for detail to not get this wrong. And, you know, having them split into groups of 5, yeah, it can be helpful in some capacity and not so helpful in others. But that's the way it's arranged. So that's how we'll deal with it. And if we're running across a row, and we reach the end, but we need more numbers, you just pop down to the next row and keep going. Just don't include that new 3-number row identifier as part of your random digit table. All right, so it'll be an interesting experience. So when we build these things, we're going to have to properly assign digits to outcomes, right? So when we're doing a random digit table, start with 0 if we're in single digits, or 0, 0 if we're in 2 digits, or 0, 0, 0 for 3, whatever. Start with 0. And then we're going to just split up numbers in a way that mimics the known probabilities. So try to keep the number of digits as small as you can, because if you start using like 3, 4, and 5 digits, then it becomes a real burden to do this. So for example, 3 flavors of ice cream, 20% strawberry, 50% vanilla, 30% chocolate. There is not so much detail in those percentages that we would need 2-digit numbers. We can get the first 10 digits and then split them into 20%, 50%, and 30%. So for example, 0 and 1 would be for strawberry. That's 2 numbers out of 10, or 20%. 2 through 6 would be vanilla. 2, 3, 4, 5, 6, that's 5 numbers. So that's 50% of the 10 digits that numbers that we can use. And then 7, 8, and 9, that's 3 out of 10. That's 30% for chocolate. So we don't need double digits. It'll make doing what we're doing a lot easier if we can keep the number of digits to a minimum. So then we use the random digit table, but again, you can pick numbers out of a hat. You can roll dice. You can flip coins, or you can use random integer on your calculator. It just depends what the problem wants you to do. Now in the homework, there's a couple of problems. I think one of them wants you to flip coins and the other one wants you to roll dice. I don't want you up all night doing that. I'll probably just let you use the random number generator on your calculator if you can figure out how, okay? So then simulate a lot of repetitions or as many as they tell us to do and then see what we get. All right, if you need more detail, like if you're trying to pick a factory worker and they're 45% white, 32% Hispanic, and 23% Black, you cannot assign single digits to these kind of percentages. So you got to go to double digits. So 0, 0, and then 44 more numbers makes 45%, and then 45 to 76, and then you end at 99. So don't start with 0, 1 and go up to 100 because you're mixing 2-digit numbers and 3-digit numbers, and that won't work. Got to stick with whatever, whatever you've decided on, 2 digits, 1 digit, 3, don't mix up with another count. So stay with the 2 digits, and like the number 7 has to be 0, 7, because if not, then you're mixing 1 digits with 2 digits, and that doesn't work either. All right, so no mixing up the amount of digits. Okay, unless you have a random number generator, like in your calculator, I'm going to teach you how to do random integer, and you can tell it, okay, I want 20 numbers from 1 to 1,000. And you don't have to worry about making it 0, 0, 1 or 4 digits, like 3 zeros and a 1, whatever. You can just tell it, I want 1 to 1,000 and I want 20 of those numbers. And the calculator will just spit them out. So you don't have to worry about being consistent with the number of digits when you're using technology. Otherwise, it's the same process as a random digit table, but we'll do the calculator as well. So just some quick terminology. Each repetition of a simulation is a trial. So you may have to do 10 trials. When you get a result from a trial, it's called an outcome. All right, and we're looking for a long-term outcome in most cases, or some kind of an estimate at it. And we're going to do this randomly. So what we're going to do is we're going to work some examples, probably just on page 7 is as far as we're going to get. And then you can finish up. Now, some of these, I'm not going to lie, will be challenging. But I don't know. Don't walk away from a challenge. I'm giving you an extra day to do it. And I do have my key posted if all else fails, but try to do the hard ones without any help, because you might be asked to do things like this in real life and you won't have somebody's answers to go by. Okay, so what I'm going to do is I'm going to move to the packet problems. I can find where those are. Okay, so let me share that. And hopefully, like I said, you have this printed out. If you don't, then try to take some notes as we go along so that, it's part of homework, so you're going to want to try to get it done. So page 7. In the first simulation, we're supposed to choose a person at random from a group where 70% are employed. So what is the probability of choosing 10 persons randomly and finding that exactly 6 are employed? Okay, so we're going to start out with assigning digits. And if we have a 70%, 30% split, I don't think we need double digits. If it was like 71 and 29%, then we would, but not 70-30. So let's let 0 through 6 represent employed persons. And then the rest of the digits, 7 through 9, that's 3 of them, 3 out of 10, that's 30%, will be unemployed, represent unemployed. All right, that's not so bad. So there's our assignment of digits. We just described it. And we're going to conduct 10, simulation of 10 trials, all right? So we're going to have outcomes for 10 different trials, and we're using line 127 of your random digit table. Okay, so if you have one handy, go ahead and grab it. There it is. And we're going to use line 127. So that's just the identifier. And we're just trying to find when we can get 6 employed people out of 10. So we need to section this off in groups of 10 numbers. So here's 5 and another 5. So if I just do this, those are the numbers I'm using for my first trial. And it's up to you how you want to mark this. And if you have your own copy, you can mark it up. You might want to do it kind of light so you can erase it. But you might want to circle people that are employed and underline people that aren't. Or just do like me, I'm just going to underline anybody who's unemployed. I'm sorry, check that. Anybody who's employed and just leave the other ones blank. So for example, 4 is employed. 3 is employed. 9 is not. 0 is employed. And then that 9 at the end, they're not employed. Then you have another 9 and another 9, and here's 4. That person that's 4 is employed, and then the 2 7s are not. So that's going to be 1, 2, 3, 4. So trial number 1, I got 4 out of 10. Hold on, I'm going to shut the door. So that is one of our 10 trials. So I'm going to go back to this table, and I'm still on line 127. I'm going to section off the next group of 10, this group right there. And let's see, 2 is employed, 5 is employed, 3, 3, 0, they're employed. 6 is employed, 4 is employed, 3, 5, but not 9. So all of those numbers except the very last one represent employed people. And so I got, for trial number 2, I got 9. And we just keep going like that. So we got 8 more to go. So here's another group of 10. And I'm going to count up the employed people here. So 4 is employed, 0, 0, 8 is unemployed. So don't underline that. 5 is employed, 1 is employed, 6 is employed, but not 9, 2 is employed, and 5 is employed. So I ended up with trial number 3, I had 8. Okay, I'm still looking for 6. I haven't gotten it yet. All right, so another one. So I'm going to section off this group at the very end. So 8 is unemployed, but 5, 1, and 1, they're employed. 7 is unemployed. 3, 6, 0, 7 is unemployed, and then 1. So 1, 2, 3, 4, 5, 6, 7. So number 4, trial number 4, I had 7. All right. So I just don't know how many of you at home have this. So I'm just going to fill in the rest. But don't forget, once you've run out of room on that line, you got to section off down here. And just ignore the 128. You're not going to count it. And then you just keep going until you're done. So trial number 5, let me just put that here. If you do that right, you should get 8. Trial number 6. If you do that right, you should get 9. Trial number 7, you should get 8. Trial number 8, you should get 5, I think. Trial number 9, you should get 5. And then finally, at trial number 10, you do get 6. All right, so the results were 1 out of 10, or 0.1. Now, there is a way to calculate the true long-run probability, but I haven't taught you that yet. So I'll just give you what the actual is and just believe that at some point I will teach this to you. So the actual probability is 0.2001. And that's not all that far off, considering we only did 10 trials. All right, I'm not sure about the counts in number 8 or 9. I think one of them might have been 4, and I may have made a mistake, but I think it doesn't matter because I know neither one of them is a 6. The only 6 that shows up is the 10th trial. So questions, guys, at home? Any questions? All right, so we're going to do another one with the random digit table. It's the same simulation question, but now they changed the employed percentage from 70 to 73%. So now we don't have a 70-30 split. We've got a 73-27 split. I don't think we can get by with single digits anymore. So we're going to have to assign our digits differently, and we need more detail. So we're going to have to go with double digits. All right. So in this case, we're going to let 0, 0 up to 72 be employed. Right. I know it looks like there are only 72 numbers, but it's the 0, 0, and then 72 more makes 73. And then we'll have 73 up to 99 be unemployed. All right, that's a pretty big change because when we go to use the table on this, every individual is no longer just one digit, they are 2 digits. So we're not going to section off 10 numbers, 2 groups of 5, we're going to section off 20 because, you know, we have twice the number of digits that we need this time as than what we did before. So we're on line 132 and we only need to do 5 of these. So here's line 132 right there, and I need to section off not 10 because we're not doing single digits, we need to section off 20. So 5, 10, 15, 20. And anything below 73 is going to be employed. So here goes. 68 is employed, 73 is not. Now here's where the gap can be kind of a bother. You got to connect the 2 with the 5. If I can get my pencil to work, 2 with the 5, because that's 25. So that person's employed. Then 52, 59, 84 is unemployed, but 29 is employed, 20 is employed, 87 is not, and 96 is not. So that's 1, 2, 3, 4, 5, 6. All right, bingo, we got a 6 right off the bat. So trial number 1 was 6. So we got at least 1. All right, now we got to section off another group of 20. So 5, 10, 15, 20, that's here. And 43 is employed, 16 is employed, 59 is employed, 37, 39, 31, 68, 59, 71, and 50. All 10 of them are employed, all 10. So that's trial number 2. and we got 10. And I'm just going to jump to the next row and do one more and then fill in the rest. We're going to go down to the next line and we're going to section off the next 20. So 45, 74 is unemployed, right? And then 04 is employed, 18 is employed, 07, 65, 56, 13, 33, and 2, 02, 1, 2, 3, 4, 5, 6, 7, 8, 9. So trial number 3 was 9. And number 4 turned out to be also 9. And then trial number 5 was 7. So we got results were 1 out of 5, right? So another way to write this, if you want, the probability of employed in this case is 1 over 5, which is 0.2. Just so that you know, the actual is equal to 0.1689. Again, you're not too far off, but we would need a lot more repetitions to get closer. So you see the difference between the single digits and the double digits? The table gets pretty bad when you have to do 3. I'm just saying, it's pretty bad. Usually problems will say, what would be the first 4 people? Like, what are the numbers for the first 4 people or something? That way it's not, you don't have to run through and pick like thousands of them. So, all right, so you can see that this works, and you can see maybe there's some pluses and minuses to it. Maybe there's some downsides. So let's move to the technology part. So you might want to grab your calculator and have that at the ready. So we're going to do the traffic light one, and then that'll be it for the day. And we'll talk a little bit about the ones remaining, just to give you some idea how to handle them. But so Cameron is coming to school every day and has to go through 3 traffic lights. And the probability that any one light is green is 0.4. All right. So the probability that it is not green, in other words, either red or yellow, is 0.6, because it all has to add up to 1. So we must assume that lights operate independently. So if he hits 2 green lights, that's no promise that the third one will be green or red. Who knows? It's going to be what it's going to be, irrespective of what he ran into before. So here's your assignment of digits. We need, we can get by with single digits here. And since we're using a calculator, we can kind of pick whatever we want to, but I'm just going to stick with the pattern that we're dealing with. So let's let 0 to 3 represent green, because that'll be 4 numbers out of 10, 40%. And 4 through 9, which is 6 numbers, will be not green. All right, so there's our assignment of digits. And we're going to use random integer on the calculator to run the simulation. All right, so let me kind of switch to calculator mode here. And I'm going to start with you guys with Nspires. So follow along with me. And let me get that up on the screen. Okay, I'm going to work on a Scratchpad calculating page. I don't see really any need to open up an actual page that's connected with other ones. That's a little too complicated for what we want. So there's going to be 2 things I want to teach you. The first one is going to be a little bit weird, but here goes. The calculator does generate random numbers. The weird thing about it is if we all clear our calculator and start like at the sort of the baseline at the total cleared state, and we start generating numbers, we'll all generate the same ones. I mean, they'll be random, but the algorithm in the calculator is set up so that we all get the same answer, which is good if I want you to get the same answer, but it's not good if you need to get something different from the person you're working with or from everybody else in the class. So you can set up your calculator to start at a kind of a random spot, and it will then generate different numbers. And you use something called seed. So you go to menu, and then you go to probability, and then you go to random, and we want two things. The next thing I'm going to teach you is random integer, but we're going to start with random seed, okay? Now, what I want to do is get us all to have the same answer. So just type in, you know, if I wanted you to do something different, like from everybody else, you could pick your own number and just keep it secret. But I want us to all be in lockstep. So just type in 1405 and just hit enter. So now we should all get the same answers. And I think it actually will work the same on the TI-84 type calculators. But anyway, let's go into the actual number generation. What it says is, let's start by estimating the proportion of 20 traffic lights that are green, repeating the procedure 5 times, okay? So we want to generate 20 numbers, all from 0 to 9 inclusive. And then we can figure out which ones are between 0 and 3, and they would be green lights, all right? So the way to do that is go back to menu, probability, random, integer. Now random number, the choice number 1, will give you like decimals, and we don't want that. We want whole numbers. So random integer, we want the numbers from 0, so type in a 0, and then a comma, which is way down here, like the lowest, most left key, and then a 9, so we want just numbers from 0 to 9, and another comma, and we want 20 of them. So just hit enter. All right, let's count. Anything from 0 to 3 is a green light. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We had 10 out of 20 for the first trial. So I'm going to jot that down, 10 out of 20. And to get another simulation, just hit enter. There's another one. Okay, I'm going to count the same numbers. There's a 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 20. 3 more to go. So just hit enter again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that got 11 out of 20. 2 more to go. 1, 2, 3, 4, 5, 6, 7 out of 20. And the last one, 1, 2, 3, 4, 5, 6. 6 out of 20. And I'm going to average those up in a minute to get kind of a result. Did you guys get that to work okay? Questions? All right. You guys with a TI-84, I need to show you what to do with yours. Okay, so you can seed your calculator, but you're going to have to go backwards. So type in the 1405, and then you want to store that into what's called random. So hit the store key, see the little arrow pops up. In order to get to those random integer and random features, you want to go to math and scoot over to probability, last choice, and there's random and there's random integer. We want the random just for seeding. Okay, so go back into math, over to probability, and hit enter. Oops, I'm sorry, that's not what I want. So math, probability, and then down to random integer, just moved on me. And the same thing, 0, and then the comma is right above the 7 key here, up to 9, comma, 20 numbers. And just hit enter. And don't highlight it or anything, you can scroll through them. And if you get done with that, you can just hit enter again, and again, and again, and just keep going. So that's how it works on the other calculator. All right, any questions on calculators? All right, so let's go ahead and finish this up. Okay, so those were my results, remember? I wrote them down. So what I'm going to do here is average those up. And this is 5 results, and I'm just going to go to a decimal. So 10 out of 20 is 0.5. 8 out of 20 is 0.4. 11 out of 20 is 0.55. 7 out of 20 is 0.35. And 6 out of 20 is 0.3. Okay, if you add them all up and divide by 5, you get 0.42. Well, remember that the original probability was 0.4. So that's really close. Worked out pretty well. And we did it really quickly, which is a lot better than with the random digit table, I think. So the other 2 questions here are a little bit advanced, not because they're super hard, but because we haven't covered probability yet. But the next question, I'll just show you how to work it. There won't be any other questions like this, so you don't have to worry about it. We're supposed to estimate the probability using this result, 0.42, that Ann will find all 3, I guess Ann or Cameron, whoever the person is, will find all 3 traffic lights to be green on her way to school. All right, so it'll be green and green and green. In probability, and means to multiply. So 0.42 times 0.42 times 0.42, or 0.42 cubed is going to be 0.0741. I don't expect that you would know that, but we will learn it in the not too distant future. The actual is going to be 0.4 to the third, which is 0.064. And again, that's pretty close. You don't have to calculate the actual, I'm just showing it to you. And then finally, for letter B, this is an interesting question. When we learn probability, you'll get questions like this a lot. It says, using your simulation, estimate the probability that Ann will find at least 1 light to be not green. Well, all the probabilities add up to 1. If you subtract from that the probability that they're all green, then you'll get the answer to the question. So 1 minus the probability that they're all green. And we already know that answer, 0.0741. So it's 1 minus 0.0741. And that's going to be 0.9259. So don't worry about that if you weren't able to answer it. It's just there. I showed you. It's interesting. So what to do with this? When you flip this over, there's 2 more pages of stuff. On number 4, you just have to explain how you would set it up. So you don't have to run the simulation. For number 5, they want you to flip coins. All right. Just try to see if you can't translate that problem into like a random integer problem, because I don't need you flipping coins. Number 6, yeah, they want you to roll a die to answer that question. You can probably convert that into a random integer thing for your calculator and run a quick simulation on it. 7 is pretty straightforward. All right, number 8, this one's going to be kind of hard. And they give you a little piece of a random digit table to work with. You can figure it out if you really want to. But if all else fails, you can look at mine. At number 9, I think is pretty doable. You're going to have to think about number 10 with the snap crack cereal or whatever they call it. That one took me a little bit of time to figure out, but I made it work and it made sense. So give it a shot. If all else fails, see what I did, see if it makes sense to you. So that's simulation. It's interesting. It's different. So I am going to ask whoever has a question to stay on the line. Everybody else can go run and start doing what you need to do, like studying or whatever. So I will say bye to most of you, and for the rest of you, stay on the call. I think we've got, what, another 5 minutes or so? When are we out of here? Yeah, about another 5 minutes. Sarthak, what's up?
What was the answer to the 1 minus probability that they were all doing?
0.9259.
Thank you.
Sure. Hi, Hoi Lee.
Hi, is there going to be a video over the simulation practice notes we just took?
I'm recording one right now. In fact, I need to shut it off.
Oh, okay.
Let's see. Do you want to stop cloud recording?